All right, worksheet 8. So after we have practiced a few rounds, I think it's not so difficult anymore, right? This particular topic. Yeah, correct. Yeah. So yeah, because we have so many practices already. Okay. You also have practices from school. Okay, and then you are going to sit for a lot of assessments as well. I know some of the schools, right? Their teachers are giving extra assessment to the students. I also have assessments for you, but I think I should start maybe just next week. Next week, we are starting on forces. So today's the last lesson we are doing energy conversion. Okay, let's look at question 1. I think there's an error in the system. Okay, the error is actually stating that C is the answer. I have notified the tech team to make the relevant changes. Answer should be, okay, look at this question again. There's an electrical iron here, or electric iron. Okay, when it is switched on, a small red bulb is lighted up, and then the iron gets warmer. So the moment you see that the small red bulb is lighted, so what does it tell you? There is light energy here, and the iron gets warmer. Iron gets warmer, definitely this is heat energy that is being given out. Right now. Yeah. Okay. Now, so, yes, I see some comments in the chat already. I like to see all these kind of comments, and we can discuss. So Natalie gave me some input, saying that answer should be either B or D, isn't it? Okay, let's look at B and D. So now they want you to identify the correct energy conversion when the iron is being switched on. Okay, so when the iron is being switched on, we have to determine, okay, so when you switch on the iron, what is inside the iron? There's electrical energy, right? Then this electrical energy is being converted to heat energy as well as light energy. Answer is actually D. But why is it not B? Why is it not B? Are y'all curious why it's not B? It says chemical potential energy here, right? Okay. Yeah. Okay, Natalie, don't worry. We'll go through this and I'll explain to you why we cannot say that it is chemical potential energy. Evan said, yeah, why? Okay, Evan, see, when we list this as chemical potential energy, where did you learn or what did you learn about chemical potential energy? Or I can ask you this, what are the things that actually have the chemical potential energy? Do you still recall? Batteries, okay, food that we eat, fuels as well, right? Very good. Yeah, so these are the things that contain chemical potential energy. Did anything stated, or was there anything that was stated in the question to tell you that batteries are used? Did anything mention about fuels being used to generate the electricity? Yes or no? Didn't, right? I didn't see anything here. So nothing in the question mentioned that the electrical energy came from fuels or came from batteries. Now, remember, sources of energy, we did mention about fuels, right? We did mention sun, yes or no? What else did we mention? Who can remember? Let's see. Okay, Avril, you also pay attention to this one, huh? Okay, what else do you recall? Yeah. Okay, Brian, coal is actually fuel. All right, you can talk about coal, the burning of coal, right? To get, to get the electrical energy eventually. So, sun is solar energy. What else? Remember running water? Last lesson, there was running water in the question, right? Yeah, so running water. So the source of running water is about gravitational potential energy, leading to kinetic energy, eventually leading to electrical energy. Right not? So can we say that it's always chemical potential energy? No, nothing was mentioned in the question that is related to chemical potential energy. That's why, Natalie, we cannot choose this one. Okay, Natalie? Understand now? There's one more actually is wind. Do you recall? The windmills, they actually can help us to generate electricity also. Timothy, remember this? Okay, good. How many of you just came back from school? I know Win Shen just came back from school. Okay, Winuli. Yeah. Let me know. Okay. All right. Good. So Giselle, you type in wind energy. We don't call wind energy. Be very careful. Wind actually has kinetic energy. Okay. If a person was holding the iron machine, will that be CPE? Tan Ma Yi, when the person is holding on to the iron, no, it will not have chemical potential energy. Okay? Because the electrical energy didn't come from the food that we eat. It's not like our energy gets converted to electrical energy. Okay, be very careful. Okay, good. So let's go on. Question 2. Paul conducted an experiment as shown in the diagram below. Okay, so there's position A here. There's a stone here. So he pulled the rubber band together with a stone backwards to this position. When he released the stone, okay, the stone then moved forward and hit the can. Which of the following shows the correct energy conversion that took place from the moment Paul released the rubber band until the stone hit the can? Let's see, what was your answer? Okay, what was your answer? Everybody put down the correct answer. Very good. How come you all didn't start with chemical potential energy? Oh, there isn't chemical potential energy. Okay, anyway, because it says that the moment Paul released the rubber band. So the moment he released it, that rubber band is already stretched, isn't it? So the rubber band has got a lot of elastic potential energy. You all recall this? Okay, but instead of elastic potential energy, I think we also discussed before that all these chemical, then gravitational, okay, we can actually just call them potential energy. Do you still recall? Yes or no? You better do, okay, write down somewhere. All right, that these chemical potential energy and gravitational potential energy can just be generalized and written as potential energy. Is it okay? Yeah, so write down somewhere. Good. So answer is D. This one, everybody got it correct. Good. Next. Now, Ken skated down a slope in a park, as shown in this diagram here. Okay, so at first he was right at the top, and then after that, he was skating down this slope. Okay, Janelle is here. Okay, now which of the following shows the energy change from the highest point on the slope to its lowest point? Let me see your answer first. Okay, not bad. All right, only 1% got this wrong. Okay, so when he was right at the top there, what does he have? He has gravitational potential energy, right? Okay, and then when he moves down, okay, when he's right here, he has GPE. Then he moves down, there's movement, so it's kinetic energy. Okay, right. So this kinetic energy also led to the sound and heat being given out. Very good. So this is the answer. Okay. Yes. Thank you, Evan. All right. Then there's heat energy, also sound energy. Okay. Now the heat and the sound energy is produced due to the movement, right? Not because of the friction. Okay. So next week when we start learning forces, okay, you will understand more about gravity, more about friction, more about magnetic forces also. Question 4. Okay, there is a diagram here that shows a water wheel, okay, which can be used to grind grains into finer particles. So a pestle is attached to the axle of the wheel. So when the wheel turns, it will cause the pestle to move up and down and therefore grind the grain. Okay, so what are the energy changes that take place in the water wheel? Okay. Question 4. All right. So you have to start. Okay, this is the water wheel. The water wheel will work only when the water falls on it, right? So the water, which is actually trapped at a higher level, there must be gravitational potential energy possessed, all right, by the water here. So the water body here has gravitational potential energy. Okay, when it moves down, definitely it has kinetic energy, right? So kinetic energy of the water, right? So when the water falls in this direction, this wheel also starts turning. So there's kinetic energy of the wheel. Okay, and then because the wheel moves, right, the pestle will start moving up and down. So therefore, that's going to lead to the pestle with the kinetic energy. Any question here so far? Hi, Janelle. Janelle, you just came back from school? Okay, Ken, thank you. Thank you for sharing. All right. I really appreciate it. I think this is a timing that is very challenging for some of you. You have to rush home just to attend the class, right? Okay, I really appreciate that. Okay, thank you, people. Now, so our answer over here, all right, potential energy of water, kinetic energy of water, wheel, and then this, yes. Okay, any question up to this question 4? No, good. All right, later on when we do the open-ended question, I have some feedback for you. Okay, and then you need to take down some notes so that you don't lose marks. Okay, Yun Shen asked, what is a pestle? Pestle, let me show you the photo. Okay. If you were to just know what we have at home, Yun Shen, you take a look at this, you probably will understand what is a pestle. Can you see this? So it's like something that helps to pound. Either here, I think it looks like some seeds. Okay, you pound it into powder form, maybe. All right, when I make popiah with my mother, I will always be helping her to pound the peanuts, you know. Okay, even though we have the grinder, right? We don't use the grinder to actually grind the peanuts into powdery form or tiny pieces. We still prefer pounding because the fragrance of the peanut oil will enhance the flavor of the popiah, according to my mom. Yes, Giselle agreed, right? Yeah, so this is the pestle and mortar. So this is the pestle. So it will heat, you know, keep heating. Then you have to imagine that in that particular question, okay, in that particular question, Yun Shen, okay, when the wheel is moving, it's actually helping to pound on the, what's that, the grains, right? In this question. Okay, Yun Shen, can you understand now? I look at the diagram, I can't find any pestle there also. So it's a little bit difficult for you to visualize. Okay, I would say that the diagram wasn't a very good one, but then the information is found in the paragraph. So inside the words, you can find how the pestle moves. Okay, come back to question 5. Okay, if you look at A, there's some energy conversion here, right? So from potential energy, it's converted to light energy. So you have to start thinking what kind of activity or actions will lead to potential energy, you know, being converted to light energy. Okay, so we know a few examples, right? It can be even like burning a candle. It can be a maybe if you have the fireplace at home,